Hello friends, let us start with the design of knuckle joint. As in last video we have seen the design analysis and complete theory on the base of knuckle joint, that what are the functions, applications, and what are the design parameters of knuckle joint, and what are the various stresses that we need to take in consideration while designing of knuckle joint. And in today's video we are going to see the actual design procedure for knuckle joint and what are the various possible failure modes of knuckle joint. Okay, so let us see guys. Please see, I am starting the actual content of this design procedure of knuckle joint. So you can see, if you please focus on this topic. If you see my cursor, this is step number 1. What is step number 1? Step number 1 is tensile failure of rods. As we know that in knuckle joint the rods which are subjected to axial tensile load, so we need to check that rods in tensile failure. So how we can going to check that rods for tensile failure? Please see, the rod may fail in tension due to tensile load P. Okay, and we know that, please see here, we know that area of resisting tearing, the area that resisting tearing is because rod is in circular member. Okay, it is circular, and what is the formula for calculating area of circle is pi by 4 into d square, d for diameter of rod. So as we seen this in notation that capital D stands for diameter of rod, so we need to calculate the diameter of rod first, that is pi by 4 into d square. Now what we need to do, equating this to load P. Now we need to equate this relation to load P, then what we get with, please see, if we equate this relation, that is pi by 4 into d square with load P, then it should be right in such a way that P is equals to pi by 4 into d square into sigma T. Now sigma T is your allowable tensile stress for the material selected, and if we are calculating this, and after calculating this, hence value of D can be determined. Okay, by this we need to calculate the value of D. This sigma T value is given in the numerical. Okay, this P value also given in the numerical, and after, if we have all the values of P, sigma T, then we can easily calculate the value of D. Hence value of D can be determined, where sigma T is equals to allowable tensile stress for the material selected. Okay, whatever material we have selected, or whatever sometimes it has been happens that some allowable stresses value, that is sigma T, sigma C, sigma S, is as always given into the numerical, and if not, then we need to consider it. Okay, so where sigma is the allowable tensile stress for the material selected. Now guys, by this step number 1, that is tensile failure of rod, we need to calculate the diameter D of both the rods. Okay, so in this way we can complete this step number 1. Now jump on step number 2. See guys, step number 2 is, there are some more categories in step number 2, that is, this is step number 2A. So see what step number 2A tells us. Please see, a diameter of knuckle pin considering shearing of knuckle pin. See guys, as we have seen in previous video that knuckle pin is subjected to shear as well as crushing failure, so we need to consider the diameter of knuckle pin by considering it in shearing failure. So what happens, please see, the pin is subjected to double shear as shown in figure, as we have seen the figure of knuckle joint. So by that figure we easily get to know that your pin is subjected to double shear. I have mentioned here, please see my cursor, I have mentioned here in bold and in other color word, that is your pin is subjected to double shear. That is why we need to write this relation, the total area that resists shear failure is equals to, A is equals to total area, A for area. Okay, A is equals to twice pi by 4 into d square. Now 2 is for, why I have mentioned there 2, because your pin is subjected to double shear, that is why we have mentioned here 2, and we have write the formula, that is pi by 4 into d square, and we know what given by d is. Therefore shearing strength, means what, we need to equate that shearing strength with the load P. P is equals to A into tau. This is called tau for shear stress. This tau subject, or this tau is we are using for representing the shear stress value or shear stress. So guys, what we have written there, P is equals to A into tau. Now again I have put the values into that. So 2 into pi by 4, what is the value for A? This is the value for A, that is this value we have put it here, 2 into pi by 4 into d square into tau. So by this relation, what we need to find out, or what we have got, please see, value of small d can be found. Please see, value of small d can be find. D should be kept minimum equal to this d for safe design. See guys, this small d should be kept minimum equal to capital D, okay, for safe design. That is why I have already told you earlier that we have assumed some empirical relation for designing of knuckle joint. So we need to use this small d is equals to capital D. So whatever the value of small d that we have found out, we need to consider that it should be equals to value of capital D. Okay, this is step number 2a. Now see next step. Now this is step number 2b. As I have told you before this slide, that we have to assume, and we have assumed some standard empirical relation to find out various dimensions of knuckle joint. And what this step 2b said us, please see, fix the dimensions using empirical relations. Now we need to fix some dimensions of knuckle joint by using this given empirical relations. Now what are these dimensions? Please see, diameter of pin is equals to d, and that is equals to capital D. So diameter of pin stands for small d, and this is diameter for rod, capital D. So guys, diameter of pin and diameter of rod, that we need to use small d is equals to capital D, that we have seen in previous slide. Okay, now outer diameter of single or double eye, that is DO, should be 2 into D. Okay, how we can calculate this DO? Value of DO we can calculate by using this empirical relation, that is twice of diameter of pin. Then diameter of knuckle pin head. See guys, diameter of knuckle pin head and collar, that is D1. Don't get confused here. Small d is the diameter of knuckle pin, and D1, small d1 is the diameter of knuckle pin head and collar. So this is quite confusing. So D1 stands for diameter of knuckle pin head and collar. And what is the calculating value formula for D1? We can calculate the value for D1 by writing this equation 1.5 times of D. Then thickness of single eye. Now how you can calculate the thickness of single eye? Thickness of single eye we can calculate, that is equals to T1 is equals to 1.25 times D, capital D. And thickness of the fork. Now how we can calculate thickness of fork? That is T2 is equals to 0.75 times capital D. So all these empirical relations we need to use to find the various dimensions of knuckle joint. Next, let us see. Now we are here on this step number 3. Now see what step number 3 tells us. Step number 3 is the checking of the failure of single eye in tension. Now see guys, now how we can design? It is very simple. It is very simple to design knuckle joint. How? We need to check various components of knuckle joint under shear failure, under tensile failure, under crushing failure. I have followed the sequence: tensile, shear, and crushing failure. Okay, so how you can as design problems are very much lengthy, and they have so much maximum number of formulas in one numerical. So how you can remember is that in case of knuckle joint, if you want to design knuckle joint, then keep one thing in your mind, that you need to check each and every part of knuckle joint under 3 different failures, that is tension failure, that is tensile failure, compressive failure, and your shear failure, or you can say tension, crushing, and shear failure. So these 3 stresses you need to analyze while designing knuckle joint. So let us see checking the failure of single eye in tension. What this step 3 tells us. See guys, area of the weakest section of eye resisting tensile failure is equals to T1 into DO minus D. Now maximum tensile stress in eye. Now what is the maximum tensile stress in eye? This tearing strength is equals to P. We need to equate this with P. P is equals to, this is the formula for maximum tensile stress in eye, T1 of DO minus D into sigma T. What is the formula for tearing strength? P is equals to T1 of DO minus D into sigma T. And we need to equate this sigma T, and we have to calculate this value, that is sigma T is equals to P divided by T1 into DO minus D. Okay, and whatever the value that we have calculated for this sigma T, that should be less than the allowable sigma tensile load which is given in the numerical, or which we have to select by some design data book. Okay, for the given material. So this sigma t is the induced tensile stress, sorry, the sigma t is the induced tensile stress in single eye, okay, and this sigma is the allowable tensile stress for given material. So you are, as we have seen in previous video, that for satisfying any safe design condition, your induced tensile stress should be less than your permissible tensile stress or allowable tensile stress. So whatever this is induced, so this whatever the value that we calculate for induced tensile stress in single eye, that should be less than your allowable or permissible tensile stress. Okay, let's see step number 4. Now, as I have told you, we need to check all the components of knuckle joint for tensile, crushing and shear failure. So see guys, we have checked single eye for tension. Now step number 4 tells us checking the failure of single eye for crushing stress. Now see, checking the failure of single eye for crushing stress. So what is the area for crushing resisting single eye? T1 into D. This is what? T1 into D. Now crushing stress is given, sigma crushing is equals to P divided by T1 into D. P divided by T1 into D. And whatever, this is sigma crushing induced, okay, this is induced sigma crushing stress, and that induced sigma crushing stress should be less than your permissible or allowable crushing stress. This is the this is the condition that we need to satisfy. This induced crushing stress should be less than or should be minimum to your allowable or permissible crushing stress. If your calculated value find this satisfied this condition, then your design will be safe. Then step number 5. Now step number 5 tells us checking the failure of single eye for shear stress. As I have told you earlier, we need to check for tension, crushing and shear. So we have, before this we have checked single eye for tensile failure. After that we have checked it for crushing failure, and now it is a time to check it for shear stress failure. Now the eye is subjected to double shear, okay, the eye is subjected to double shear. So maximum shear stress in eye is tau is equals to P divided by T1 into DO minus D, and that should be less than or equal to allowable or permissible shear stress. So this is induced shear stress, and this induced shear stress should be less than your permissible or allowable shear stress. And if you satisfy this condition, then it means your what we say, single eye is safe in shear failure. Then this is step number 6. Now we have checked one component, that is single eye. Now we need to check another component, that is fork end in tension. As I have told you, we need to check each and every component of knuckle joint for tensile failure, for crushing failure and for shear failure. So we have checked one component for all these 3 stresses, that is the component name is single eye. Now this is next component is failure of fork end in tension. See, checking the failure of fork end in tension. So area of the weakest section of fork resisting tensile failure is twice of T2 of DO minus D. So maximum tensile stress in fork is sigma T is equals to P upon twice T2 of DO minus D, and that should be less than your allowable or permissible tensile stress. By this we need to calculate this induced tensile stress in fork end, okay, in fork end component. Previously we did it for single eye end component, and now we did it for fork end component. Okay, the next step, this is step number 7. In this step number 7, what it is clearly said that checking the failure of fork end in crushing. Previous we have checked fork end for tensile failure. Now we are checking the fork end for crushing failure. So projected area of pin in the fork is twice T2D. This is the standard formula for given that. And crushing stress is equals to sigma crushing is equals to this sigma crushing stress we are calculating for fork end. Don't get confused with that. We need to calculate all the tensile, crushing and shear failure for each and every component of the knuckle joint. Keep this thing in your mind, which may makes it easy for you. Okay, so sigma crushing is equals to P upon twice T2 into D. P upon twice T2 into D, and it should be less than or equal to your sigma C, allowable or permissible sigma C, that should you have considered or which you have given in the numerical. Then step number 8. Step number 8 is checking the failure of fork end in shearing. See guys, checking the failure of fork end in shearing. as we have checked fork end for tensile and crushing failure, so now it is turn to check it for shearing failure. So each of the two rods or each of the two parts of the fork is subject to double shear. So that is why total area resisting shear is equals to, it is very easy, see guys, 2 into DO minus D into T2. So same formula we have put it here, tau is equals to P upon twice T2 into DO minus D, which should be less than or equal to allowable permissible shear stress. And if you satisfied this condition, then your design will be safe. So guys, we have what we did, we have did first we have checked the single eye for tensile, crushing and shear failure. After that we have checked the fork end component of knuckle joint for tensile, crushing and shear failure. And now see what it is next. So instead of that, we know that your knuckle pin is subjected to double shear. Okay, your knuckle pin is subjected to double shear, we know that. So the pin is subject to double shear as shown in figure. So we have written this formula for that, and shear stress in the pin for, and we need to calculate the shear stress in pin, that is tau is equals to P upon twice of pi by 4 into D square, and it should be less than or equal to allowable or permissible tau. So where tau is equals to allowable shear stress for the material selected. So if your tau induced is less than your tau allowable, then it means your design will be safe. So see guys, we have seen the 9 steps of knuckle joint, and let me revise you that step number 1 is tensile failure of rods. By this step we need to calculate the diameter of rods. Then in this step, in 2A step, we need to check the diameter of, we need to consider the diameter of knuckle pin, that is it should be considering shearing, and we know that pin is subject to double shear. So by this formula, value of knuckle pin, that is value of diameter of knuckle pin, value of diameter for knuckle pin can be easily calculated. After this 2B steps tells us that we need to use some empirical relations. If we are designing one knuckle joint, then we need to use some empirical relations, and with the help of these empirical relations we need to calculate overall dimensions. This is design of knuckle joint. Now step number 3, we need to check the single eye under tension. Then we need to check single eye under crushing failure. After that we need to check single eye for shear failure. Similarly, if I am talking about fork end, then I want to check, or I need to check fork end under tensile failure. Then again fork end should be tested in crushing failure, and fork end similarly tested as tensile and crushing, it should be again check it for shear failure. And finally we need to check shear failure of knuckle pin. So guys, in this way these 9 steps makes complete justice with the designing of knuckle joint. If you have successfully calculated all the values according to these 9 steps for knuckle joint, it means you have successfully designed a knuckle joint. So let's see numerical on knuckle joint now without wasting time, as the video length is increasing. So numerical on knuckle joint. See guys, I am reading the problem, and all of we should going to do this practice. Problem 1 is, a knuckle joint is used to withstand a load of 20 kN. Design the joint if permissible stresses are sigma T is equals to 36 Newton per mm square, tau is equals to 14 Newton per mm square, and sigma C is equals to 70 Newton per mm square. See guys, see this sigma T, this tau and sigma C all are the permissible or allowable values for tensile, shear and crushing stresses in Newton per mm square. So in this numerical, they are clearly asking us for designing a knuckle joint, and they have given us the load value in kilonewton that should be converted into Newton by us, and they have given all the permissible stresses values, that is under tensile, under shear and under crushing. So what is the first step of solving any problem regarding design? Let me tell you, the first step of solving problem of design subject is to write the given data. Whatever data is given to you, that you should be write that data as it is. That is the first step of your solving problem in this subject. So I have just, you can see, I have just written all the data which is given in this numerical here. This P is equals to load carried by the rods, that is 20 kilonewton. We need to convert it into Newton. So how we can convert it? 20 into 10 raised to 3 Newton. Then sigma T is equals to 36 Newton per mm square, it is given. Tau is equals to 40 Newton per mm square, and sigma C is equals to 70 Newton per mm square. Now as we have seen the design procedure of knuckle joint, what is the step number 1? Step number 1 is tensile failure of rods. Now see, the rod may fail in tension due to tensile load P. So we know that the area resisting tearing, you need to follow same design procedure as I have taught you earlier. We know that area of resisting tearing is equals to pi by 4 into capital D square. So tearing strength of rods, we need to equate this relation with the load P, that is P is equals to pi by 4 into D square into sigma T. We have put all the values in this formula, just put the value and get the answer. Such principle is applicable here. We have put all the values and by that we can easily got value of D. The value of D is 26.59 mm and we have converted it into as round figure, that is 28 mm say. Hence value of D is determined. See guys, here in this way we can calculate the value for D. Now next step number 2, we know that fix the dimensions using empirical relations. We know that, okay, so diameter of pin, we know that diameter of knuckle pin, that is small d, and this is diameter of rod, and this small diameter of knuckle pin should be equals to diameter of rod, that is, so we calculate the diameter of rod which is 20 mm. So ultimately your diameter of knuckle pin also 20 mm. Outer diameter of single or double eye, that is DO is equals to twice D. So we have D, okay, we have this D 20 mm, so 2 into 20 mm is equals to 56 mm. Diameter of knuckle pin head and collar is equals to D1 is equals to 1.5 times D. So we have multiply diameter to 1.5, so we got 42 mm. Then thickness of single eye, T1 is equals to 1.25 times D. So we just written here 1.25 into 28, so 35 mm. Thickness of 4, that is T2 is equals to 0.75 D is equals to 0.75 into 28, so it is 21 mm. So guys, you can see here, you can easily clearly see here, we have fixed the various dimensions of knuckle joint by using various empirical relations, and all these empirical relations that I have calculated here, we need to use this in solving further numerical. So we jump to step number 3. We know that step number 3 is we have to start it for single eye checking tension failure. Okay, so checking the failure of single eye under tension. See, we have what is the weakest section eye resisting tensile failure is T1 is equal T1 of DO minus D. So tearing, we have equate this equation with the P. P is equal to T1 of DO minus D into sigma T. Sigma T we have calculated here. You can see we have just written this formula, and this formula also we have seen in design procedure also. We have just put the values all that we have fixed with the help of empirical relations over here, and we have calculated it 20.40 Newton per mm square. And this is induced sigma T, and see what is value for give permissible value of tensile stress, that is 36 Newton per mm square. Please see guys, 36 Newton per mm square, and what we have calculated and what is our calculated value is, that is 20.40. It means our induced tensile stress value has been minimum as compared to what we say permissible value. So our design is safe. And again we need to check single eye for crushing failure. See, checking the failure of single eye for crushing stress. So here is the formula, that is crushing single eye T1 into D. So sigma crushing is equal to P divided by T1 into D, and which should be less than sigma C. So don't get confused here guys. This 20 into this is not 103. Please see, this is not 103. This is my typing mistake. This is 20 into 10 raised to 3, because we know the value for P. The value for P is 20 into 10 raised to 3. This is not 103. I am repeatedly tells you that this is not 103. This is 10 raised to 3, 10 raised to power 3. And value for T1 is 35 and value for D is 28. So here we can easily see sigma C value is 20.408. And what is the value for sigma? This is induced. This is the value for induced sigma C. And what is the value for permissible sigma C is given in the numerical, you can say 70 Newton per mm square. So it is too less than permissible value. So it means our design is safe. Then next, please see, this is step number 5, that is we need to check single eye for shear stress also. Now here is the formula that we have seen in design procedure also, and here we have written the formula, and we have all this value. See, again this mistake is happen here. Please see, don't get confused. Value of P is 20 into 10 raised to 3. This is not 103, this is 10 raised to 3. And T1 value is 35 and 56 minus 28. So we got 21.40. And what is this is induced shear stress value, and it should be less than your permissible shear stress value. And what is the value for permissible shear stress is given, that is 40. Okay, 40. So it is exactly half of induced. So it means that our design is safe for single eye. Okay, so in this way we have checked the single eye for tension, for crushing, and for shear failure. Now what is our step number 6? We need to consider fork end for tension, fork end for crushing, and fork end for shear. Now let us see. This is fork end for tension. This numerical formula that we have given to twice T2 into dO minus D, and tearing strength is equal to twice of T2 into dO minus D into sigma T. So I have just written the formula, that is sigma T is equals to P by twice T2 into dO minus D, and I just put all the values into this formula, and my answer will be sigma T is equals to 17.0068 Newton per mm square, and which is less than 35 Newton per mm square. It means my design is safe. Again I need to check or consider the fork end in crushing failure, that is projected area of pin, that is twice T2 into D, and crushing stress, that is sigma crushing is equals to P divided by twice T2 into D, and which should be less than sigma C. So here I have put all the values and got 17.0068 Newton per mm square. It means our design is safe. And last we have again considered the shear failure of your fork end. So we have just put all the values into this formula, that we have formula also we have already we have seen in design procedure, it is twice of dO minus D into T2. So we have just put P by twice T2 into dO minus D. So we are left with this 17.0068, and shear stress per allowable is given 70 Newton per mm square, which is too small. It means our design is safe. And what is our final step? Our final step is to check the knuckle pin. Okay, that is failure of knuckle pin under shear. So what it is, we need to check, that is this is area of resisting the shear failure, that is A is equal to twice of pi by 4 D square. Why I have used 2 here? Because our pin is subjected to double shear. And see guys, shear stress in the pin is equals to tau is equals to P upon twice of pi by 4 into D square, and that should be less than or equals to allowable shear stress or permissible shear stress. So guys, here you can easily find out that is tau is equals to 20 into 10 raised to 3 divided by twice 2 into pi by 4 into 28 square is equals to 16.24 Newton per mm square. So finally you need to write this statement at the end of your numerical that you solved in the examination, as all the induced stresses are within permissible limits, hence the design is safe. Okay. So in this one sentence all your meaning is has been satisfied successfully, that as all the induced stresses are within permissible limits, hence the design is safe. See guys, in this way we can successfully design the knuckle joint. So if you like this video, then please